Okay, so this is part 2 of the segments and bisectors, section 2.1 notes. We didn't quite get to talking about how we apply our new vocabulary into proofs, so we're going to do that now. If you remember, our new vocabulary, this section 2.1, included segment addition postulate, bisectors, and midpoints. And we had perpendicular in there too. So these are the concepts that we want to now look at how this affects proof writing. Okay, so this first one, in every case what we want to do is first mark our diagram, label the diagram with given information, and then proceed with our proof. So if we take this given information and mark our diagram, PA is 3 times x plus 4. AT, and remember AT, segment AT, with no bar over it, you know, not that, just no bar, means the length of AT is 4x. And then PT, they tell us, is 26. So we're going to look at our diagram, we're going to look at our information, and we're going to say what conclusions can we make, or what one of our new vocabulary can we apply here. So this one's going to be a segment addition postulate. Remember, in all proofs, what we want over here or somewhere is a general statement, a general equation that we can substitute into. So we're going to basically state the segment addition postulate here in a general way. PA plus AT equals PT. Segment addition postulate. We're not going to plug any x things into it yet. We're just going to apply the postulate, which is the general. Now this is already an equation, has an equal sign. So we are now ready to substitute into that equation. So all three of these can be substituted in to say 3 times x plus 4 goes in for PA, plus 4x, which goes in for AT, equals 26, which goes into PT. This is substitution. Now we just proceed like we always did with our proofs. You're going to solve this algebraically. First thing we need to do is distribute, show every single step, and then we're going to combine like terms. And then we're going to subtract. Oops, I'm running out of room again. Subtract. And then we're going to divide. Remember, it's better to just keep going down, but I ran out of room. So this is going to be x equals 2. Division. We're trying to prove PA equals 18. Make sure you're always getting to what you're trying to prove. PA equals 3 times, we're going to plug in our x as 2, and that's substitution. And then we just simplify. PA is 18. Simplify. Okay, so if you remember, I don't want any steps in between these last two, substitution, then simplify. Some of you on tests went from substitution to simplify up here. You don't want to do that. I got to see all the steps done out for algebra, you know, so that you're solving for x and showing me all the steps. Okay, this next proof is a different set of givens, a different Okay, so we have MI bisects angle HMJ as one of our givens. Now, like I said, the first thing you want to do is mark your diagram and label your diagram. Those are two different things. Marking the diagram is marking it with congruence marks for either angles or segments, right angle symbols, parallel lines, whatever it is that you can mark in your diagram, you should mark. So this given, MI, bisects angle HMJ. If you remember what bisect means it cuts it into two congruent pieces. So that means we're going to cut angle HMJ into two congruent angles. So these two angles we should mark congruent based on reading this given. Okay, our other two givens, measure of angle 1 is 17x plus 3. Measure of angle 2 is 20x minus 6. So we can put that in here, 17x plus 3 and 20x minus 6. So again, with a proof, we need a general statement. We need a general relationship between these angles that we can write an equation for and substitute in. So the general equation is not going to be just under here from our diagram like it sometimes is, like vertical angles, linear pairs. We can just look at our diagram and write a general relationship. But that's not true here. Here, our general relationship, the clue that we have as to how angle 1 and 2 are related, comes directly from this given. So we need to arrow it down under this given. If MI bisects angle HMJ, then we're going to make a conclusion. And the conclusion we can make is that angle 1 is congruent to angle 2. Basically what you're doing here is when you mark your diagram, you're going to then make the conclusion of exactly what you marked. We marked angle 1 congruent to angle 2, therefore we're going to state angle 1 is congruent to angle 2. Directly pointing down from the given that allowed you to mark the diagram that way. This reason is going to be definition of that key word that we read, right? MI bisects angle HMJ. We read that and we know, oh, that means it cuts it into two congruent pieces because of the definition of bisect. Then we're not quite ready to substitute in yet because we need an equation, not a congruence. So we go one more step down, turning angle 1 congruent to angle 2 into the measure of angle 1 equals the measure of angle 2 by definition of congruence. At this point, you are ready to substitute because you have an equation. So the equation you're going to substitute into is measure of angle 1, which is 17x plus 3, equals measure of angle 2, which is 20x minus 6. Substitution. And then you would solve from here. Solve for x, plug back in to get the measure of angle 1. I'm going to let you kind of finish that one on your own. Come back and you can check your answer, but sort of finish that one on your own. Okay, so there it is, finished. Subtraction, addition, division, substitution, simplify, and that proof is done. Okay, if we look at the other side, these are ones for you to try. This proof is exactly modeled by the first one we just did. This proof is exactly modeled by the second one we just did. And this one is a little bit different because it has the word midpoint in it. What I want you to do is do these three on your own. I'm going to help you with this one. B is the midpoint of AC. If B is the midpoint of AC, we should be able to go over to this diagram and mark these two things congruent. B is the midpoint of AC. That means B is right in the middle, and the conclusion we can make is that AB is congruent to BC. That is the conclusion we can make from here. Reason, definition of, in this case, our keyword was midpoint. To turn this into an equation, like we learned about in our notes, when we want an equal sign, meaning the measures or the lengths of these things, all we do is take away the bar that's over these congruence statement, right? So here it's just AB with nothing over it equals BC with nothing over it by definition of congruent. Okay, at this point you would have to put the rest of your givens here, etc., and then substitute in. And then finish the proof from there. Okay, so you guys should try these 3 proofs on your own and check Google Classroom for the answers, and we will follow up in class. Thanks.